Okay, subtopic 9.2, which is on graphs of simple harmonic motion. So in this subtopic, you should be able to discuss the following graphs. Discuss mean you have to be able to draw the following graphs when they are asked in exams lah. So some of the graphs are on displacement against time, velocity against time, acceleration against time, and lastly energy against displacement. Okay, so firstly we are going to look at the displacement graph, where the displacement could start at a positive or negative amplitude, and then it can also start at equilibrium point here. Okay, so for the displacement graph, we do have two types of general equation, where it can start with cos ataupun sine. Okay, so if it starts with cos, we know that the graph will start at the amplitude lah. I mean, dia tidak start dari zero macam ni. Okay, so they start at the position of the maximum displacement, which is the amplitude. Okay, so if you are asked to discuss this type of graph, you should also be able to state what is the amplitude, lepas tu what is the period, macam to complete one cycle macam tu. So this is the period lah. Okay, and then after that you also have to be able to draw the graph for velocity. So velocity punya graph, you just basically gonna derive this equation here, which will give you this equation. So if we look at this, it has a negative, meaning that the graph will start at the negative axis. So this is a sine graph, so it starts at 0. Kalau kamu blur, macam how do I know where is the point for each of this for each of the time? You can actually just substitute macam let t equal to 0. So at t equal to 0, kita dapat apa? Sama juga macam ni, let t equal to 0, let t equal to 1 ka, macam tu lah. Okay, and then you also have to be able to discuss the graph for acceleration. Well, basically acceleration will have a function of negative cos after you derive it. And then kejap let me just check if the acceleration punya equation is correct. Negative cos, betul lah, yeah. So derive sine, dapatlah cos. Okay, so this is the equation for acceleration punya graph lah. Same thing applies to these three. So at this point, the displacement starts at the equilibrium point lah. So the graph will basically starts like this, and then if it asks you to find the velocity and acceleration graph, just derive this equation and then you'll get to this equation. So if you don't know how to start, you just let t here equal to 0. Okay, so cos 0 is equal to 1, if I'm not mistaken. Yes, cos 0 is equal to 1. So it's gonna be equal to just the omega amplitude lah. So that's why kita letak omega a di sini. Okay, and then same goes to this acceleration equation lah. Okay, right, so lastly, you have to also be able to draw this energy displacement graph. Make sure when you are drawing this, you have to label it lah. Okay, so U is for potential energy. Potential energy pun starts with U, so that is easy for you to memorize. And then for kinetic energy, dia bentuk N, so this is for kinetic energy. Okay, so kamu boleh ingat just one of it, which is the potential energy. So just opposite tu maksudnya itulah yang kinetic energy lah. Okay, so make sure you also label the negative and positive amplitude, and at this point here juga, where at that point is basically the total energy lah. Okay, at this point here. Okay, I feel like if No, that's basically it lah. Okay, so I think I'll add a diagram for the graph of acceleration against displacement. Because I think I did. Yeah, obviously I didn't add that into your notes. So basically, it's something like this. So this graph is for energy pula acceleration against displacement. Okay, which is the definition of SHM kan. So this is the displacement x. So this is the diagram lah. Okay, nih boleh lah to. Nanti I'll add a proper one to your lecture notes before uploading it to GC lah. So this is negative A. This is positive. The penalty is positive. So this is the positive amplitude. So at this point, this is basically A omega squared. This one is negative A omega square. So this graph is for acceleration against displacement, where the gradient will give us the negative omega square. Alright, okay, so that is basically the theory part for graphs of simple harmonic motion. So in this subtopic, you just have to be able to draw the following graphs lah. Alright, that's it for 9.2.